Okay, let's continue with the 2008 multiple choice test. This is number 16. If sine of xy is equal to x, then dy over dx is equal to. Notice that we want to find the derivative, but this is not a explicit function, meaning that it is not y is equal to, and everything, all the x values are separated from the y. We see the y's are mixed in, the y's mixed in with the x. So this means that we have to go through implicit differentiation. And then also, because we have x and y being multiplied together, that means that there's also going to be a product rule that's going to be involved. And also, the derivative of sine of u is sine of u times u prime, so there's also a chain rule portion as well. So the derivative for sine of u is cosine of u times u prime, and we can start off with that. So we can allow the u value to be xy. So cosine of xy times the derivative of xy, and because x and y are both variables and we want to go through and we want to find their derivative, they're being multiplied together, so we have to go through product rule. So f prime g plus f g prime. When we find the derivative of y, we have to attach a dy dx because this is implicit differentiation. And don't forget, the right side, x becomes 1. And then we can just take our steps now to work towards getting this dy over dx by itself on one side. So first, I'm going to distribute this cosine of xy through. So I'm left with y cosine of xy plus dy over dx, x cosine of xy is equal to 1. I'm trying to get this dy dx by itself, so I'm going to subtract the y cosine of xy. So I'm left with 1 minus y cosine xy. And finally, I can divide this x cosine xy to the other side, and then that matches up with our answer choice D. Okay, number 17. The graph of the function is shown and has a horizontal tangent at x equals 2 and x equals 5. So we see the slope is 0 at x equals 2 and x equals 5. Let g be the function defined by g of x is equal to integral of f of t. So all this is saying is that this f of t is the derivative of the g of x graph. And if I want to find g prime, then that's going to leave me with f of x because I'm just going through the second theorem of calculus. So g prime is equal to f of x, meaning that this is the first derivative graph. And if this is the first derivative graph, then any x intercepts will be where the slope is 0, and anywhere above the x-axis represents positive slope, below represents negative slope. Okay. And it's saying, where does the graph have a point of inflection? So point of inflection is going to occur at the max and the mins of our derivative graph. So the max and mins are going to be x equals 2 and x equals 5. And this is concave up because it's positive slope, concave down because it's negative slope, concave up. So that means point of inflection will occur at x equals 2 and x equals 5. Okay, number 18, in the xy plane, the line x plus y equals k, where k is a constant, is tangent to the graph of y equals to x squared plus 3x plus 1. What is the value of k? And if we know that a line is tangent to a graph, then there's a lot of things that we can a lot of information that we can take away from just this word here. So because a line is tangent to a graph, what that means is that at their point of tangency, the line and the curve are going to share the same ordered pair, but they're also going to share the same slope. And because they share the same slope, we can set their derivatives equal to each other and use that to help us solve for x. So we can set these two equations equal to each other. When we do that, we have y equals negative x plus k, and we have y equals x squared plus 3x. And we can also set their derivatives equal to each other. So the derivative of negative x plus k is simply negative 1, and the derivative of x squared plus 3x is equal to 2x plus 3. Okay. And if we set their derivatives equal to each other, we're going to get -1 is equal to 2x plus 3. Solve for x. X is equal to -2. And so we know that x is a -2. And it says, what is the value of k? So if we want to find the value of k, we first need to find, we're still missing the y value. So to find the y value, we can plug -2 into the original function. And when we do that, we get -2 quantity squared minus 6 plus 1, which gives us -1. So once we have our y value and our x value, we can now use this piece of information to plug in and find the missing variable, which is k. So x plus y is equal to k, so therefore -2 minus 1 is equal to k, and so k must be equal to -3. Okay, number 19. What are all the horizontal asymptotes for the graph of this equation in the xy plane? And if we want to find the horizontal asymptote, this is a subtle but important point, is that obviously you're going to be finding the limit as x approaches infinity, but you're also going to find the limit as x approaches -infinity, because there may be different asymptotes, so we have to make sure that we check both cases. So first, let's check the infinity. So infinity, let's just go ahead and plug infinity in for x, and we see that's going to go to infinity. This will go to -infinity, so positive over -infinity, and these are both the same values. They're going to cancel out to just be -1. Okay? And these coefficients are going to be negligible because these are such large values that they're going to eventually cancel out. Okay? And then let's find limit as x approaches -infinity. And so 2 to the -infinity is same thing as 1 over 2 to the infinity. And this is essentially the same thing as 0, right? 1 over infinity will just basically be 0. Same thing, 2 to the -infinity is same thing as 1 over 2 to infinity. So that's going to go to 0. So then we have 5 over 1, which reduces to be 5. So we have two horizontal asymptotes at -1 and at +5. Okay, number 20. Let f be the function with a second derivative given by f double prime. What are the x coordinates of the points of inflection for the graph of f? So we know that first off that our critical points must come where f double prime is equal to 0. These are already factored for us, so we can just set f double prime equal to 0, pick out the x values, which is 0, 3, and 6, and then we can look to see whether there's a change in sign at each of these critical points. Okay, so the key thing to remember is that just because your f double prime is equal to 0 is not sufficient a sufficient enough test to determine whether it's a point of inflection. There also needs to be a change in sign at each of those critical points. So we have to make sure we make a sign line, and we see if we plug -1, we're going to get a positive. If we plug in 1, we'll get a positive. If we plug in the 4, we're going to get a negative. If we plug in a 7, we'll get a positive. So therefore, the only change in signs will be at 3 and at 6. There's no change in signs at 0, so only 3 and 6 will be points of inflection. Okay, number 21, a particle moves along a straight line. The graph of the particle's position, x of t, is shown. And the graph has a horizontal tangent at x equals 1 and x equals 5. Sorry, t equals 1 and t equals 5. Point of inflection at t equals 2. For what values of t is the velocity of the particle increasing? So another way to interpret this is saying, where is the acceleration going to be positive? And if acceleration is positive, what that means in terms of our graph is where our second derivative is positive. And so that's asking where is the graph going to be concave up. Okay, and we know the point of inflection, they tell us, is at x equals 2. Now this is the original graph, so we can just look at the shape. So this shape is parabola opening up, so this concave up, and this shape is concave down. So we know that concave up is going to be from 0 to 2. So concave up means acceleration is positive, which means that the velocity of the particle is increasing. Okay, number 22, a rumor spreads among a population of n people at a rate proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. If P denotes the number of people who have heard the rumor, which of the following differential equations could be used to model this situation with respect to time where K is a positive constant? And so first off, we notice that we see this word here, rate proportional to the product. So we know that this is going to be in the form of y is equal to kx, right? And a rumor spreads at a rate. So rumor at a rate is represented by dp over dt, because p represents the people who have heard the rumor. So rumor spreading will be the change in the number of people who have heard the rumor, is equal to is proportional to the product of the number of people who have heard the rumor. So we're having to multiply those who have heard the rumor with the number of people who have not heard the rumor. So the people who've heard the rumor is represented by P, and the people who have not heard the rumor is the total number of people minus those who have heard the rumor. So let's say there's 100 people who are in this population, and there's 40 people who've heard the rumor. So if 40 people have heard the rumor, then that means there's 60 people who have not heard the rumor. So 100 minus 40 will give us 60. So 40 times 60 will be the product of those who've heard the rumor and those who haven't heard the rumor. So we can set it up with this form, and then that will match up with part B.